We are revising topic 1.3, elemental composition of pure substances. Another interesting and easy lesson. So, types of pure substances. There are three types of pure substances. First one is called molecular substances. So, in this, you will have molecules. You will have molecules, and molecules means they must have a covalent bonding. When I say covalent bonding, the bonding should be between only non-metal atoms. So they are individual molecules and they are bonded covalently like water and carbon dioxide. There can be many more, HCl, then you can have CH4. So you have to just look at the periodic table and see if it is made up of only non-metals. And when I say water gonna exist by itself. So this is one water molecule, this is another water molecule. There are so many and they are interacted to each other or they are bonded to each other by a hydrogen bonding. So they are individual molecules and they don't need to combine with anybody else to exist. Then comes atomic substances. For atomic substances, you will have only atoms. You will have only atoms, so there will be individual atoms, and they are most of the time noble gases like He, Ne. So helium, neon, all the noble gases, they don't need to combine with anyone. They can exist by themselves. So this is helium. So this is how the helium can exist. So just by one atom. I want to add here in a molecular you can have Cl2 as well, F2. So this is how it can be diatomic molecules too. Then comes ionic bonding. Ionic bonding, you will have ionic compounds, so you will have ionic bonding. For an ionic bonding, you should have a metal bonded to a non-metal. So they are made up of positive and negative ions. So metal will have a positive charge and non-metal will have a negative charge. They are all arranged in a three-dimensional structure called lattice. So lattice is this. Suppose this is how the cube could be. So this is the three-dimensional structure, and then you will have a metal, non-metal, metal, non-metal. So there will be a alternate arrangement of ions. So there are negative ions, negative, positive. Yeah, and you call them as formula units. So wherever you see ionic compounds, they will have a formula units, and there will be so many ions existing together. They can't, NaCl can't be just one Na and Cl negative. There will be many of them existing together. So they can't exist as a single unit like molecules. So they will this is how they're gonna exist. So any ionic compound will have a 3D structure called crystal lattice. Then comes law of definite proportion, very easy and simple. It states that a chemical compound always contains same elements in the same mass ratio, okay, regarding the size of the sample. So there will be a fixed composition of elements in such compounds. The mass ratio of the elements is constant, all right, and it applies to all samples in a compound. So it is applicable to all the compounds. Like water, in a water, if you see the hydrogen has a mass of 1, but there are two hydrogens, 1 times 2, so it comes up to 2 is 2, and oxygen is 16. So what is the ratio? So the ratio is 1 is to 8. So if it is water, if you take 2 grams of water, if you take 20 grams of water, if you take 200 grams of water, the ratio of hydrogen to oxygen will stay 1 is to 8. All right. So look here, another example. So as I was talking about, so sample A has 2 grams of hydrogen and 16 grams of oxygen. So ratio is 1 is to 8. On the other hand, if you have 5 grams of hydrogen and 40 grams of oxygen, so the ratio is still 1 is to 8. The ratio must remain constant. That's very, very important. So that it helps in verifying the chemical formulas and check the purity of the compounds. If it's water, the ratio gonna be this. If it is other than this, it means it is not a water. All right. Then comes empirical formula. Empirical formula means the lowest whole number ratio of the atoms in a compound. So look at this. Do you have a molecular formula? Molecular formula is the actual formula of the compound, and empirical formula is the simplest ratio of the atoms. So all these numbers, the 6, 12 and 6, they are divisible. You can simplify them. When you can simplify them, that becomes the empirical formula. H2 and O2, again you can simplify it as HO. 2 and 4, you can simplify it as, because they are all divisible by one common number, so it's NO2. Another case, an interesting one, if you have 2 and 5, they are not divisible. So the molecular formula and the empirical formula is same. All right. So make sure all the numbers must be divisible by a common number. If they are not, then the molecular and empirical formula gonna be same. Then it is very important to know how to calculate or determine the empirical formula. There are steps. Let's solve a question. I will apply these steps to solve a problem. So if a compound contains 40 grams of carbon, 6.7% of carbon, 6.7% hydrogen, and 53.3% oxygen. So first place the elements carbon, hydrogen, oxygen. 40 grams, 6.7%. Sorry, I'm saying per grams, just ignore it. It's percent, and then 53.3%. Now the percent can be directly written as grams. So I was constantly saying it as grams as well. So you have to do nothing. When you see a percentage, just write it as in the form of grams. You have not to perform any calculation. So this is percentage, this is mass in grams. Sometimes you will be given the mass, okay. If it is given in a percentage, then directly write it as a mass. You don't need to do any calculation. Then you will find the moles. All of you know how to find the moles. Number of moles is equal to mass over molar mass. So you're gonna divide 40 and the molar mass. So molar mass of carbon gonna be 12.01. Hydrogen 6.7 is 1.008, and this is 53.3 divided by 16. All right, so let's do the calculation. 40 divided by 01, so it comes out to be 3.33. 6.7 divided by 1.008, so it is 6.65. If you are rounding off, so round it off correctly. 53.3 divided by 16, so it comes out to be 3.33. So you have got this moles. Next step, you have to simplify. For simplifying, you're going to choose the smallest mole. Which of them is the smallest? So you can see here the 3.3 smallest. Divide all of them with 3.3. So this comes out to be 1. This also comes out to be 1. 6.65 divided by 3.33. So it comes out to be 1.99. So it can be rounded off as 2. So what is the empirical formula? C1, you can ignore 1, CH2, and this is O. So this is my empirical formula. I'm giving you a quick recap of the steps. If the mass is given in grams, absolutely fine. If it is given in percentages, you're going to change it to grams by just rewriting grams instead of percent. Then you can find the moles. Moles is equal to mass over molar mass. Then you're gonna find the simplest ratio. How do you find the simplest ratio? Divide the moles with the smallest mole. Smallest mole. And then you will get your empirical formula. All right. Now let's see some question. Which of the following substance is best described as consisting of formula units rather than discrete molecules? So molecules means you are talking about covalent compounds. When I say covalent compounds, you will only have non-metals. This formula units means you're talking about ionic compound. You will have a metal with a non-metal. So which of the following substance is best consisting of formula units? So when you go to periodic table, you should all have a secure understanding of metals and non-metals. You'll see carbon as a non-metal, oxygen as a non-metal. Hydrogen is over here with group 1, but don't confuse it that it is a metal, it's a non-metal. So you have non-metal and oxygen is non-metal. Sodium is the group 1, so this is metal, and chlorine over here is a non-metal. So as we said, metal and non-metal will be the formula unit. Carbon is a non-metal and hydrogen is a non-metal. So the most suitable answer is NaCl. Read the question well, underline the important things, and then start answering the question. Which of the following substance exist? I want you to pause the video and try to solve the questions by yourself. All right, here we go. Which of the following substances exists as a individual atoms? Individual atoms. So now you're looking for atoms rather than molecule or formula unit. So molecule you would have probably guessed. As we said, they are covalent compounds. Formula units, they are ionic compounds. So what would be the answer? They said atoms. So answer goes straight helium, because this is a molecule, this is a molecule, and this is my formula unit. All right. Next question. Which of the following correctly describes the structure of CaCl2? They are asking about the structure. Now first identify what type of compound is this. Calcium over here belongs to group 2. It's a non-metal. And Ca is a metal. My bad, sorry. This is a metal and this is a non-metal. So metal and non-metals, you know, they are ionic compounds. They are ionic compounds. They have a crystal lattice. Crystal lattice. So look for the answer. All right, I see a lattice of calcium ions and chloride ions. All of you know calcium belongs to group 2, so we'll have a charge of +2. Cl group 17 belongs to this. So you're gonna have your answer as C. Next question. 2 samples of the compound carbon monoxide are analyzed. So carbon monoxide analyzed. So sample 1 has carbon 12 and oxygen has 16 grams. So look at the ratio of both of them. So which of the best explain these results is about the laws. So 12 and 16 must be divided by a common number. So here the common number can be 4. So when they divided by 4, it's 3. And this comes out to be 4. Similarly, 24 can be divided by 8. So 24 divided by 8 comes out to be 3. And it comes out to be 4. So you can see here, though the masses are varying, but the ratios are same. When the ratios are same, they are that follows the law of definite proportions. Is this clear? Next one. A compound contains 4 grams of hydrogen and 32 grams of oxygen. In another sample, if another sample contains 2 grams of hydrogen, so here 4 is to 32. So this should be divisible by 4, all of you know. So this comes out to be 1:8 ratio. If another sample contains 2 grams of hydrogen, how many grams of oxygen should be present according to law of definite proportion? As you can see, for 4 grams there is 32 grams. So now you have half of it, so oxygen will also become half of it. The half of it is 16 grams. So answer gonna be C. I would suggest you, sometimes it is a mental math calculations, more time in thinking and less time in choosing the answer, because thinking is a bit long process. But once you know the answer, it's very easy to choose the answer. Pause the video and try to do this question by yourself. I think it's a repetitive question. I have done it in the previous part of the video. So the answer gonna be CH2O. So you can refer to the previous part. All right, next question. A compound is analyzed and found to contain. So you have got 3 elements. Determine the empirical formula of the compound. So first thing is it is in a percentage, so you're gonna simply write it in the grams. So you have 13.0 grams, 34.8 grams. Then you're gonna find the moles. So how to find the moles? You're gonna show all your steps. You can make a table. You can have a table like this. So now I'm finding the moles. So mole divided by the carbon is 12.01, hydrogen is 1.008, oxygen is 16.00. So it comes out to be 52.2 divided by 12.01. So it comes out to 4.35 moles. 13.0 divided by 1.008, so it's 12.9. moles, and 34.8 divided by 16.00, so it comes out to be 2.18 moles. So this is the moles. Then you have to find the simplest ratio. For a simplest ratio, you need to divide all of them with the smallest mole, and smallest is 2.18. This comes out to be 1. 12.9 divided by 2.18. This comes out to be 5.92. 4.35 divided by 2.18. This is 1.99. 1.99. So you can't have fractions in the formula. So this can be written as 2. This can be written as 6. And of course, so the formula is C2H6O. All right, this is my empirical formula. Next step, the molar mass of the compound. Now you have to determine the molecular formula. For molecular formula, you need one number. Let it be represented by N. So here you will write the molar mass. How will you get that N? Molar mass divided by empirical formula mass. So this is my empirical formula. For this, I will calculate the mass. So how do I calculate so was the molar mass 92. Empirical formula 12 times 2. Let me put it as 12.01 times 2. Hydrogen 1.008 times 6. And oxygen is 16. So you're going to solve it. So it comes out to 46.068. So 92 divided by this number, you get as 1.99. So you can again round it off as 2. So you got this number. So next step is you're gonna take this number C2H6O and N. So N comes out to be 2. So it is C2H6 2. So C4H12 and O2. This is how we're gonna solve this question. Now practice more questions. Yes, so you're gonna practice more questions to master the concept.